Good morning, colleagues from Working Group of SDG Indicator and Working Group of System of National Accounts. Good morning, Pak Agus Sutanto from RS Plus, who will be our trainer also for this next several days. I'm happy to welcome you to the training of data estimation and imputation. Actually, the main goals of this training is to provide us with capacity to be able to conduct some methods for data estimation and imputations. We think that this kind of training is important because we understand, we acknowledge the limitation, the challenges that we face in recent times. We understand that for some of important data, we don't have reliable sources. And also, even we have surveys, sometimes we cannot conduct the survey in regular basis. That's why, especially in this kind of situation, in the middle of pandemic situation, and also in the emerging needs, particularly related to fourth industrial revolution, for example, and other global initiative where the data is needed in more frequent way, in more detail, more disaggregation. So the ability for ASEAN member states, particularly for statistical authorities, to be able to provide the data on regular basis is crucial. That's why we hope this week, through this training, will be led by Pak Agus. We hope we can improve or we can enhance the capacity of ASEAN member states as well as ASEAN Secretariat, hopefully to be able to solve some of the issues that I mentioned earlier. Pak Agus would like to offer some kind of technique which is not so complicated, I guess. And the software that will be used also is a free software. So hopefully after the training, all of us can do something, based on the result of this training. So I would like, I don't want to spend much time. So I would like to say thank you again. Thank you for Pak Agus and RISE Plus to keep supporting us in the capacity enhancement of ASEAN member state and ASEAN Secretariat. And great appreciation, of course, to all ASEAN member states through these two working groups for keep supporting us in the development of ASEAN statistics. Hopefully, we can have fruitful discussion in this next 5 days. Please stay safe and stay healthy. Thank you. Next, remarks and introduction. I would like to give the floor to Pak Agus. Please, Pak Agus.
Thank you, Pak Anang. Dear participants from ASEAN member states, Pak Anang and colleagues from ASEANstats, very good morning. On behalf of RISE Plus team leader, Mr. Paul Mendel, I would like to welcome all of you to this data estimation and imputation training to be held 6 to 9 December for ASEAN member states and on 10 December for ASEANstats. And to thank you for attending this training. The training is organized by ASEANstats and RISE Plus, as you know, and supported by the EU through the RISE Plus project. This is particularly, as Pak Anang mentioned, meant to provide support for the improvement of ASEAN SDG indicator and publication through the proper handling of missing data on SDG, and also to provide coherence imputed data. Also to provide skills and tools to do proper estimation and imputation in general. Hence, it should help the quality of SDG publications, at least at the ASEAN aggregate level. Yeah? Missing data is, in fact, a fact of life. Yeah? But yet, many of us statisticians in the NSO normally do little or nothing when actually, in some extent, we can do something. Mostly this is because of the misunderstanding or lack of the understanding of the methods and the mindset. Normally the statistician have mindset only to deal with hard data. On the other hand, we know that analysts, economists, biostatisticians, they do a lot on this kind of data estimation and imputation to improve their analysis. We see major international organizations like the UNSD, World Bank, IMF. They have more complete data than NSO because they did some form of some kind of data estimation and imputation. And people use that. And in fact, the data imputation methods was developed and used much by biostatisticians. Yeah? The methods was scientific, and the latest methodology normally believed to be reliable. Yeah? To give at least coherence figures, not, of course, we cannot have the true value, yeah? But some figures which are coherence with other relevant indicators. So through this training, we'd like to provide participants with understanding and the tools about the tools and how to use the tools, methodology, and to encourage you to apply the method for better analysis. Here we also invited participants from the SNA, System of National Account Working Groups, as Anang mentioned, in addition to the SDG working group, because the methods actually can be applied in any fields of statistics. And SNA is one of the fields facing missing data every day, yeah? Or missing and lack of data every day. So we'd like to encourage member states to embark on exploring the use or more use of data imputation and data estimation techniques. In fact, actually it is best if this is done by the National Statistical Office at national level, yeah? I mean, at national level. Because you understand better what data situation, you have more supporting information and supporting data to help you to come up with more plausible and coherent estimated or imputed data. So hopefully the training will encourage you to do more, if not yes, so far, on data estimation and imputation. With this, I would like to end my remarks and thank you and wish you all a fruitful training. Thank you.
Nick, you still mute.
Sorry. Yeah.
Next, we will have a photo session. Our colleague Tari will help us with this session. And so over to you, Tari.
Thank you, Mbak Hanik. To all the participants, before we started our training, like usual, we'll have a photo session, which is a virtual. So if you could please turn on your camera so we can see your bright smile on a Monday morning before the training started. You know, starting the training with smile wouldn't be a problem. So if you could please turn on your camera and we'll have our photo session. Okay, I still see some, all right. Some are still coming on. All right, okay, so I have 2 pages here on my screen, so we will take the picture 2 times. Yep, okay, still coming on. All right, okay, so I'll take the picture 2 times and on my count. Okay, everybody, you give me your best smile. Okay, on my count. Smile, 3, 2, 1. And another one, please. On my count. 3, 2. Okay, 3, 2, 1. Thank you. Over to you, Mbak Hani. Oh, Mbak Hani still muted.
Sorry, my bad. Thank you, Tari. Now I think we're gonna start the main course of the training. So I will give back the floor to Mr. Agus. Please, Mr. Agus.
Thank you. Okay. According to the agenda, we should start with the scope of the training. Do you have it on, can you see it on the screen? Everyone?
Yes. Yeah, we can see your screen.
Okay, thank you. Yeah. This is more or less the coverage of the training. So the goals is very clear to help you be able to handle the missing values properly. Because everyone can do the estimate, but we will be using the standard methodology, which hopefully can produce more data which are coherent with other information, the data. And for that, we need to know, to learn how to use the R, yeah, because we are going to use the R, which is free, yeah. We need to learn the basic operation of R and to do the data manipulations. I mean, when we have a data, we need to have it uploaded to the R, and then we need to see what it is inside. Yeah. So this is more or less the topic of the data manipulation and exploration. And after we are familiar with our operation and how to explore our data, to clean our data, to manipulate our data, and to visualize it. Yeah. Of course, this is not meant to teach you to be a professional data visual visualization expert. Yeah, I think some of you are more experienced than me in this. Oh, by the way, I don't know how much you know about the R and this data imputation, but I assume we can start from the basic, yeah. But let me know if it is you think that this is not necessary. Yeah? We'll start with the basic one. And in addition, we need to know at least the big picture of what people do in data estimation. So we learn a bit about the regression analysis and time series analysis. Again, not so much to help you to become an expert, because of course this will need 2 or 3 semesters, yeah. But this will give you at least the most important messages, the most important thing that you need to know about how to use regression in time series analysis. What is the danger? What is the good thing? Yeah, and why it is necessary in this training? Because this is also related to the imputation techniques that we'll be discussing. And we will have to understand, yeah, the concept of missingness. Yeah, of course, first to detect. Sometimes people assign missing values with NA, sometimes with blank, sometimes with dot or with 999 or none or something else. Yeah? We need to be able to explore our data, whether there are such things of codes that indicates the missingness. Yeah? But more importantly, we need to understand the nature of the missingness, because this will help improve our imputation. Yeah? Is missingness really random? Yeah, or is there any relation with one specific variable, for example? And the second one, of course, will create some bias, yeah, because it's related to other variables. But the first one is provide us with more confidence in estimating the or more leverage in doing the imputation, yeah. And the magnitude, of course, how much the missingness in our data set, yeah. And if it is small, of course, we can just forget about it, especially when the missingness is random, yeah. But if it is quite substantial, then we have to do something. Then we need to understand, of course, the methodology for data imputation itself. This is basically in general the coverage that we will be dealing during this 4 or 5 day trainings. More detail, as I mentioned already, actually, we need to be able to turn the data, raw data, into some insights and knowledge. Yeah? We only receive raw data, and there are missingness there. So we need to be able to explore to help us understand or to get some insights, yeah? To prompt us to do more exploration, more analysis. So we will learn the most important tools, and which hopefully provide some foundation to understand the most important tools and to encourage you to do to search more. Yeah? And then strengthen the relevant data estimation techniques I mentioned, and to gain the capability of examining the nature and messiness of the data, and able to apply the standard methodology of data imputation and estimation. This is more or less the coverage, and more detail the scope here. I will not go through, but we just like to emphasize that one, of course, on data manipulation and visualization, then the regression methods, and concept of messiness, as I mentioned, and then the how we identify missing data, and then the standard method of data imputation. We need to learn about. So we need to learn about R, as I mentioned, how to install it, how to operate, and then to learn about the most relevant R packages. Yeah? Because to address this issue, we need this package. To address another issue, we need maybe another package. Yeah, so we need to know and get familiar with that, and explore what kind of data sets available in R. So many data sets are available when you install R. Yeah? So this is normally important for the training to help us familiarize with R. And then we can apply this to the real data that we are dealing with. In this case, we will be dealing with the SDG. Yeah? And a bit technical about the data structure and data frame, we need to know. But in general, as Pak Anang mentioned, it's not so complicated. Unless you want to write the codes your own, yeah. Maybe this you need your programming skills. Yeah. Otherwise, as long as you need it just to solve the ordinary problem, normally you just need to use the available functions in the R. Yeah? There are functions in the R, and then you just combine together with data, apply the function to the data, and you get something. Of course, there are some rules, yeah, that we need to follow, but you don't need to write codes from the scratch. So that's why we need to have a lot of practice, actually. If you learn technicality from the scratch, this will be a bit frustrating. Yeah, but if you know the basic thing first, and then go develop a bit, and then you will get more and more without a lot of frustration. Yeah? And important the data, that you know how to import the data. So we have to be able to load the data to the R from wherever it comes, you know, from the R-based package, from your local computer, from the websites. There are some materials here in the Dropbox, of examples to help you to do this. For example, to extract data from the World Bank, World Development Indicators, from the Yahoo Finance, and from the IMF, World Economic Outlook because they have set up a database which can be accessed by R. Yeah? Not necessarily to understand how to use the API, yeah? But just to know their link, and then some codes maybe just to get their data. Of course, there are some complications, but don't worry because here I would emphasize first on the basic thing that you should know and make you comfortable to move forward. Yeah. I don't know how far you know about the R's, but I assume you can go from the basic one. And we learn on the tidying the data. Tidying is making the data ready for the R, yeah? Transforming the data, and then some data visualization and modeling. And then analysis, regression. Again, I emphasize the merit and the caution that we have to understand, yeah? Not so much the statistics. When there's no statistics, we will not be talking about statistics, but we'll be talking about the tools, understand the tools, how to use them with properly and smartly. Yeah? I mean, there are some data we can address with simple method, so we do it with simple method. Okay, and the time series, of course, time series analysis. The process is very long, yeah, and requires you to do some iterations to estimate many models and to come up with one which may not be also optimal. So there is now the technique, it's called the auto-ARIMA, which we can rely actually because they will give us the optimal one, yeah, out of the many models that they provide. Of course, when I say optimal, it's just from the point of view of the criteria, which is the minimum, more or less, average standard error, more or less, yeah. But not from many other things. But even if you do it manually, of course, you can incorporate your judgment, your understanding of the data, and your expertise, yeah. So not necessarily to follow the output of the auto-ARIMA. But here we will learn about auto-ARIMA and the process. Of course, we will enter this process, yeah. So you know the process. And handling of the missing data in R, as mentioned earlier, to identify the missingness, the nature, then how to address it. And finally, we apply this to the SDG missing data with R. Not necessarily with SPSS because I don't have time to do it with SPSS, but with R minimum. Maybe I will provide you with some links to this on the SPSS. See, I think that's all about the scope of the data estimation and imputation. Any remarks from on this? Okay, if not, then we can move on to the next item, which is the R basic, and then working directory, setting up working directory and data loading. But before that, I would like to know if some of you still need some help to install the R or R Studio, because this is the most important prerequisite, the most important tools you should have to follow the training. Yeah? So should I walk you through the installation, or all of you have installed the R? Let me know. R and R stages. So sorry, how to know whether participant is still needed some help. Should they send yes to Tari when
Maybe,
they need?
sorry, Pak Agus, if the participant have a problem with installing or downloading the R, you can raise your hand or type anything on the chat with me so I can guide you.
Okay. It's not that you're not able, maybe you just don't have time, but it's really important that you have the R and R Studio in your laptop, yeah? This is the look of the R. You haven't seen. I know many people from Indonesia already master on this.
Pak Agus, there is a technical question from Thailand. On the chat box, he asked if he can use our studio on Anaconda.
Yeah, we are going to use the R Studio and R, yeah? R Studio. Okay, I just maybe go through briefly the video available. So in case you don't have it, and then you can do it while I'm playing the video. Okay, let's do that. Just to install the R, so first we have to install the R, yeah? So we need to download first the R installer. Need to go to this website and click it, and we click the website here. You got this window and click the CRAN, and then go to this cloud art project. You see, go to download R for Windows. We're using the base R, and yeah, this version, and then it's downloading. Will take some time. Okay, when you're done, you just double click here or click here, and then you install. Yeah? Now you start with installing. That's the usual process of installing. Yeah, this is very easy. Just click next, next, and next. Okay. Put it on the desktop. This I would recommend. Easy, and they're installing. So once you finish, you get this window. Yeah? The R. This is the R, and you collect the data just to have some sense what data are in there. This is the many data available in the R. Okay, little bit about exploring the data. This and the Irish data. We call the Irish data to our R environment. That's all on the R installation. So having installed the R, we can install the R Studio, because the R is only meant actually for professional, yeah? But R Studio have some convenience for users, more user-friendly. This is the R Studio. Download the installer. Should go to this rstudio.com and click enter. Yeah, rstudio.com and click enter. And it's from us to this. We take this one. Download free. Yeah, you don't want to pay, right? Then, yeah, download for free. Take this one. And it's installing. It's installing, takes some times. Okay, when it's done, you can go to your download file, you install it. This is from the download file. You have this RStudio installer. You, right click, and then you go to the run administrator. And you just follow the installer process, Okay. You can see more in the video, but more or less that is the steps. Okay, if any of you don't have this R and RStudio, just install it, download it, and install it while I'm discussing the next topics. Okay, any question? Next thing is one of the most important steps, which I recommend, in addition to the installation. This is about creating an R working directory. Let me get the file. Yeah. So the importance of setting up the working directory. I would really recommend that you have this kind of folders. This will facilitate our working with the R. So you can put it on the desktop or anywhere you like, but you need to have one folder. Here I call it TEI, estimation and imputation. And these are the folder of the R project. So within this R project, before that, in addition, you need one folder maybe for the document, like the PowerPoint presentation, etc. I put it here, but here are really the R project and R script. This is what I mean by R script. So, for example, under project one, I call it the basic operation. So this is this one, the basic operation. Here you name the subfolder also basic operation, and inside you have this one, this kind of this one with the small r. This is the R project. The R project is your working directory today. Here you will have a few R scripts. This one is R scripts with the R, R scripts. R scripts is actually a collection of commands, command, and information. Yeah, you need to deal with certain things. For example, this is about how to operate the R. You put it here. And then here about how to load the data. You put it here. And in the second project is called data manipulation and visualization. The project is called P2 data manipulation and visualization. I call it MVIS. Yeah. So under this, you have a few here, later, a few scripts. One is on the data manipulation. One is on the using the ggplot2, and then step-by-step manipulation, step-by-step ggplot, etc. You may have many other R scripts. So we'll have 6 here. We have 6. You can imagine if you put everything in one directory, only have one, will be very difficult to find whatever you want to work on. Yeah? But here, for example, you want to work on the regression, you just go to project 3. Yeah, project 3. You want to do the data visualization, you go to the project 2. On the time series, you go to projects 4, etc. So here is the structure of the folder. Inside we have the R working directory. And the good thing, the most important thing is that when you work on one of the scripts, for example, you work on this data visualization ggplot2, and you produce the graphics, you produce the output, or you export the data, they will automatically fall under this project data management and visualization. Not here, not here, not there, automatically here. So it's very convenient if you have this kind of structure, yeah. And if you have data files, like here I have the SDG for R, and this is in text format, and then SDG for R in Excel format. If you put it here, it is easier for you to load the data. Okay, and you import data from outside, and then you export it. It will come here automatically, and not on the other project. Okay, so this is very convenient, and I think we will increase the efficiency of working with the R. Yeah, that is. I would like to underline about the importance of having this structured folders and R working directory. So here I would like to show you step by steps how to create those things. You can have look at the video later, or at the document available. I'll show you. Here we have the video 3. Yeah, the 3 for working directory. And then some step-by-step on creating working directory. I will show you directly through this R. Yeah? When you open R, the first time you install, you don't have this thing here, still empty. And everything's empty except here, there's some note about the R. Yeah. So we have, we're working on R Studio, we have 4 windows. Top left here, we call it the script windows, where we write the scripts. And then down here, we call it the console window, where we can also execute command here. And on the top right, we have the environment window. This is where the data, when it is loaded to R, will appear here. The file will appear here. Data and other objects that you created during the working session, yeah, will be appear here. So we will see a little bit about what are objects in the R. Objects can be the data and the vectors, yeah, will appear here. And when the data has not been here, you cannot use it yet. Yeah? And then down here is normally where the plots will appear. This is the plots area or the plot area. But you can also see the packages that you already have installed. When you install the R, there are many packages already available. They come with the R installation. But many or some you will have to download because they are not from the base R. They come from the contributor. Yeah? Contributor. And after you install, they will appear here. The hub, yes, you can find the hub. And again, this is the file where you store your scripts in the project, R project. Now let me show you here. If you have created the R project, on the corner, top left corner here, you will see the name of the R project. P2 Data Management and Visualization. And here is the name of the scripts, yeah, you have created. This is the same as here. Okay, let me start now with creating the project. Suppose this is a blank R Windows. To create the project, you can click the plus here, create project. But the conventional way is open file here, you create new project. Okay, maybe you can follow if you have not created this project because we will be working on this. And I don't want to confuse you to find the file. Yeah? So once you create the file, open create the project, you get this. And if you click, you need to click again here. In my case, I have some project already, and I have just worked on here, project 6. project 6. Yeah, project 6. But I want to show you how to create a project under project 1. Yeah. So I have to change this. So go to browser, and this is where I put everything under the desktop. So this you should select where you want to put the project. Suppose you are working on the project 1 here. So you click this one. Disappear, page 1, and then open. You can give name here. Any name, but I use already my old name. So now I'm creating another one, for example, B1 PEI basic. Yeah, it should be one word. You connect it with the dash with the one. So here, because you already go to the right folder, appear P1, yeah. Otherwise, this project will be stored under P6 directory. So after this, we can create the project. So now you can see here in the corner, P1 TEI basic has been created. Yeah. This you can just click, come back to the 4. Yeah. So you see here, I don't have anything yet. Don't have anything yet. So suppose I want to create my first script. So we work with on the R file, yeah, on the scripts, not on the this directory, because this is just the directory. So you want to create a script, you click this one, or here you can go to new file or script. So you're creating a new script. You can click, for example, here for the moment, just create first script. On project 1. Yeah, you need to put this hash sign, but otherwise the R will think that this is a command. If you put the hash sign, the R know that this is just a command. Yeah, command. They will not execute this. For example, this is all the content of the scripts, and then you can save as, because you don't yet. You can save as. If you see, we are still in the project 1, TEE basic. We are not anywhere. We are still here. So we will put the script under this. For example, you will name the scripts script 1, project 1. Okay. And if you save it, you have it here. Everything will be under your working directory of project 1. Yeah? Okay. If you want to work on the script 1, for example, later, you better not click this directly, but if it is in this environment, it's fine. You can click this directly. But if you are from outside, you better go to the, for example, you close this, then you want to go to the script 1. You better start from here. Click here. So for example, this is all, then I close this. Okay. And now I would like to continue working on project 1, on script 1 maybe. Don't click this. If you click this, the whole content of your RStudio will be there. The whole file RScript, and it's confusing. So better you click this one. And you're in project 1 already. It's not anywhere in project 1, and you can continue working on this script 1. Once you finish with this and you want to create another script, you can click, use this, for example. Create. And you create second scripts. This will be on something else, yeah? And after you're done, and then you save it, you provide the name. For example, you call it to script to project 1. Okay, now you save it, you got it here. So these two scripts are located within this working directory of project 1, yeah? Okay, now you want to create the second project, yeah, not the second project. So go here, it's fine. Or you can go, as I showed you earlier, to project. Yeah? So suppose you click here, same thing, new directory, new project. And here you're still in project 1. You're still in project 1. You need to make sure that you place the working directory in the project 2. So browse and locate the directory which is under project 2. New project 2. So it's there. You can open it, and then here we are already in project 2. So we just create the name of the project 2. Project 2. Something like this. You create the project. Here you have project 2 already, but you don't have any R file here. You don't have any scripts here. You don't have anything here yet. So you can click this, or you can, whether you can, scroll this, if needed. And now you want to create the first scripts for project 2. So you can click this, R scripts, and script 1, project 2. Example, that's all you want to write in the scripts, and then you save it. Save it as, you don't need to worry here again because you already are in the project 2 directory. Just provide the name here. 1 script Script 1, yeah. Script 1. Project 2. And save it. You have it here. So that is how you have to create the working directory. And I would recommend you have this in your computer so to facilitate and you in the working with the R. Yeah. So again, yeah, you should have you should have this kind of structure. First, this document here, you can put everything here, the document, and then after you create the project, it's still an empty project, no problem, but you have this R files organized neatly by the project, relevant project. So you should have 6 of them, yeah? And so 3. P1 on the basic operation, P2 on the data visualization and management, P3 on regression, P4 on the time series, and P5 on the data imputations. Actually, one more, if you wish, P6 for the SDG. And here I put data management and visualization in one working directory. You could have split them into 2 if you wish. Yeah, P2 1, for example, you call it for data manipulation, and then P22 for the data visualization. This is still also fine. Yeah. So if you expect, you will have plenty of the R scripts, and then you can split this into 2 from the beginning, yeah? Because if you have it in one here, and then later you want to split it, it's a bit complicated. Yeah, you need to change the path. Yeah. Yeah. So from the beginning, I would think you want to split this into 2 to make it 2 folders. So P2, 1, for example, for data management version. Yeah. Then P22 for data visualization. Okay. That's all about the importance of the working directory and how to create the working directory. Any question or suggestion? Should see the chat. Yeah, it's very timely. I estimated we finish at 10 and now it's 10, yeah, with the working directory. So next we move on to the basic operation. I don't know if some of you don't have the R Studio yet, but you really need it to be able to follow my training here, because we will show you the, we will walk you through the R basic here with the R file. So you need to have the R file already. And then also on the data manipulation. We will walk you through this with the R and data manipulation. We have 3, and then data visualization we have 2 that will be needed in this session. So may I know if some of you need time to install R or RStudio? Otherwise, we can proceed. Please inform Tari if you need some time to install it. Maybe we can break earlier rather than proceeding, but some of you don't have the R and RStudio. Please inform Tari if you need time to install this. Okay. Yeah, I believe all of you has the R and RStudio in place. So let's move on with the next agenda, which is on the getting started with the R. Yeah. So we first to familiarize ourselves. Okay. we should first familiarize ourselves with how to operate the R, and then we will learn how to do little simple data exploration, and then continue with other examples of more data manipulation. So let's work on the R basic. Yeah. Yeah. I would start by saying that because we are going to be working with data, this for analysis or for purposes of imputation for other things, yeah. And related to this training, this is for us to be able to handle machine values using some data. And the data could be small, but could be also big. The file could be very, very big. So imagine if you're working with a big data. Small data, maybe you don't need to do lots of exploration, cleaning, etc. But for big data, you really need to understand what is it in your data, what the size of the data, what variables are there, yeah? Whether there's missingness, etc. And then you need to explore a little bit about the data to get some sense, yeah, of what's inside the data. Then you need to learn how to explore and clean your data. Yeah, this is mentioned already. And to know how to clean the data. Yeah, well, there are always more than one way of doing that. And it's the base R. We use the base R before the R Studio. They use the base R normally. But with R Studio, with the new latest package, it's normally more efficient if you use the more on the new package. When I say package, it's not necessarily the R package. Yeah, within the R package, there are many packages, be some kind of module or something. But there's, for example, tidyverse package. This is within the R. So there's a gapminder package. Many packages. In total, actually, there are more than 15,000. But we don't use a lot, of course, yeah. And why there's so many packages? This is because people are developing they're working on something, yeah, and then they develop a package so other people can use it, yeah. So then they contribute to the R, the CRAN, yeah. So this is called the contributed package. But even the base package is already very many. But of course, sometimes we need the contributed package. Later, we will learn while we go. Yeah? So back to this introduction. Yeah. So we need to know how to clean the data. You need to be in the data frame format. So there are many types of data, but best if you can put it in data frame format. You can imagine data frame is like a matrix actually, like a matrix. we have the same column, number of observation, then number of columns horizontally and vertically. Yeah? And this should be in the data frame format. And when you're working with the time series analysis, the data must be in time series analysis format. Yeah. So you can change it to time series analysis. But for the data frame, it's very convenient. If your data before you input it to the R, it's already in base in the data frame format. But you can also force this data and to change it to the data frame when you are doing with the R. But normally there are some functions, some codes that don't work well with other format other than data frame. So better if you have it in data frame. And I mean, to have this, you have to have the data in the text file. You read the data in text file, then it will directly become the data frame. And then next is to do a simple analysis, get a glimpse of the data, and learn about data manipulation. Yeah. Now we look at the first package in the data set that we will be using for this training. Yeah. The most powerful package, one of the most powerful packages that we will be using is called the tidyverse package. Tidyverse package. If you install this, you will have a few packages. So this is a set of packages. Yeah. Inside you will have a ggplot2 package. You will have a dplyr package. You have the render package, etc. We will use some of them. But this one is the one you should install. Install this. Yeah. This will help us work with the data manipulation and exploration more efficiently. We'll show you. And it will come with ggplot2, as I mentioned. And this ggplot2 also help us working with the graph more efficiently rather than using the base R. So I will not show you how to use the base R for the plotting, but there is a material there in the Dropbox, but we will use the ggplot2 because this is more efficient. And when install this tidyverse, it comes with some data set. Yeah, there's a data set available that people can use for free. Of course, normally we will be talking about the time, the update, the most updated type maybe until 2018. Yeah, not until the latest one, but it's very useful for training this data imputation and training and imputation. Okay, first data we will encounter is called the iris data. Iris is the name of flowers. Yeah? Ladies know this, iris. Now I have the picture here, the image. This is the iris flower. And here we have observation of 150 observations of iris flowers. What they measure are these two components. You look at the iris flower, there's a big part of the flower. This is called the sepal, and the small one is the petal. So they measure the petal length here, and then measure the petal width. Also the sepal length and the sepal width. And this is for 3 types of species, 3 species. It's called the Setosa, versicolor, and virginica. So each of them is 50 observations. In total, 150 observations. So the data frame has 150 rows and 5 variables. These are one of the most commonly used data frame for training purposes. But we will introduce few more data because they have more complications, which will be important for us to do the data exploration. Yeah? Okay. Because I will be walking you through this, so I would suggest that we work within this directory. So let's go to the project 1, basic operation folder, where we have the P1R basic operation project. So this with the square icon is the project, and this is the script. I have a few more scripts, but we will be using with this script, the R basic script. So click on this P1 basic operation. Again, you click the R project, the R project, not the R file. This is R file, or we call it scripts, R scripts. You click the P1 R project, and then we will be creating the scripts. Okay. So if you have already created the script as I showed you earlier, then you will have already in your here, the right bottom of the window, you have the project, P1 basic operation project, and 2 scripts, 2 R file. So click on this project, and then we will follow with the R basic. I will walk through to the R basic. So here, let me show you. I will have to go to this folder. And this is the new one, sorry. This is my one. Okay. To the basic operation. This is the project. I should click this and then later go to the R basic. Okay. Of course, in your script, you still don't have anything except that what you wrote earlier. Scripts one for project 1 here. Right? But here, if you open your R and then for now, I would suggest you copy and paste the scripts that I provided. And then you will experience little by little. But if you type everything your own here, and then normally you will have an error only due to the typing. Yeah? Maybe this is a capital R. Maybe you don't have this closing parenthesis, or you don't have this quotation, etc. Yeah. So I would suggest that you copy this one. Scripts. Yeah, this one. This script in your folder. It's called script for the getting started with R, the R basic operations. Just copy the whole thing and paste them into this here. Paste it here. And I will walk through this codes line by line. Again, because I don't want to lose much time only due to the wrong typing, the typo. So if you have copied them, you should have this. Okay. And this first lesson is on loading. I should do the loading. This is the basic operation. Okay, that's correct. Oh, I got the wrong one. And this is the one. Yeah, it's supposed to be this one. Okay. This one, basic operation, you copy here. And first is to get familiar with the iris data. Get familiar with the basic operation, but we will use the iris data. When iris data is available with the R, when you install the R or R Studio, will comes with the data, many data, and one of them is the iris. Yeah. I will show you. Example. This is how we want to view what data in the R. Sorry. Yeah. First lesson. If you put you write a command in this script window, you can either highlight or put it at the end of the line, and then you should run this. This is run icon, run. Yeah? Click that run. But if you use this below window, this is called the console window. You can also do this. You just enter. You just enter and you can see the here. So these are the data available in the R, normally people use and contributed. This air passengers data, we will use it for time series analysis. And CO2, BOD, this is also commonly used. And here is the air quality also. There have different nature, different complication, which is good for training. But first is the most simple one. This is the iris data. There already. Yeah. For this kind of data that comes with the R, you don't need to install it. You don't need to load it. Just use it here. So again, if you work on this window, you can write this, and if you want to execute this command, just click the run. You get the same thing. Yeah? So what is the difference working on this script and in this console window? I would recommend you work always on the script, yeah? Because on the script, you can have this long even command, is the scripts, we call it. And you can save it for later, you can use it for later, you can further develop it for later. But if you write it here, everything, it works, it gives you the same output. But after that, it's gone, yeah? You don't have the file, you don't have the R script, you don't have this R file, yeah? So next time you have to write again from the beginning. Okay, so start to be always using the scripts, okay? Again, after you for example, here we are going to start with the iris. We want to view the iris data. We don't know anything about the iris data except that what I inform you, the number of observation is 150 and the number of variables are 5. Yeah. So what else? So we have the view this. So you write the view and then you put in the end of the line, or you can do this. Because if you have many codes in one script, for example, here few lines, maybe it's confusing whether you may think this is the end of the line, yeah. So better you highlight this and then send it, run it, yeah. Okay, back to this. If you view this and click run, see, you know the content of the data. We have 5 variables or columns, call it. Simple length, simple width, pixel width, and this is the species. The species is Chitosa, and then we have versicolor and virginica. Okay. Maybe that's all we know from here. And if there are NA, of course you can see there's NA here. Yeah? But imagine if you are working with a big data. You will not scroll down until 500 lines. Yeah. So you need to do something else. Going back to this, our basic. This is the output. You can close. Okay. You're here now. So what is this command leading to? Okay, let's see. This will bring the data to your R environment here. Sometimes it comes here, but for certain data, it goes directly to the, you can click this, directly to the data line. So this iris data now is within the environment of your R. So you can use it for your analysis, for data exploration, etc. Yeah, because you already have it in your environment. Before this, the R is only sitting somewhere. You can view it, but you cannot analyze it. Okay. Now, first step, maybe you want to know the number. Yeah. Again, put it here. Click. What's problem? Since the iris. Okay. Yeah.
Excuse me.
Yes, sure.
Before we using the count function, we need to install the tidyverse package first.
Oh yeah, I forgot. Yeah. Do I have to install this? Not yet. Yeah. Yeah. Okay. You need to install the tidy first. Thank you. How to write the code? Install. Right. And here it already guide you. Install packages. And here we provide the opening and closing parentheses. But you need the question mark. Yeah? And then you call it tidy first. Yeah. But actually I have installed this, yeah? So I don't need to run this. But if you don't have installed it, you have to run this, yeah? Run this. I have installed this, so I will not run it, but I have to load it. Load to bring it to my environment. Insert tidy first. Okay. Why it's not? Load tidy first. Not correct yet. Let me see. Yeah. Maybe I was working on the. Let me install them first. Sure.
You can use library tidyverse.
Yeah, okay, I install this, so you can also follow install.
Maybe
and
you
then,
doesn't use the library tidyverse. Maybe
but it should work. Yeah, I don't
they're not
know.
unactive.
See. Okay. Type wrongly. I don't know. Should work now. So libraries light up in green, and then this tidy first. Okay, so run. So it's there. Yeah. That's the problem. Okay, this and this gone. Yeah. You can execute this three line together. Okay, now you get this. The count, the number of observation is 150. So some of the function, they need that you install or load this tidy first, yeah. But many do not need. Yeah, but better if you have to install this first. Okay, this is the data again, and there's 150. You can close it. Okay, there's another statement that you need to know: the length, the 5 variables. This is the dimension. 150 rows, 5 variables, 5 columns. This is the structure of the data. Let's see what it is, right? The structure tells you about each of the variable, ship length, for example, and the type. This is numeric, yeah, this is numeric. Simple weight also numeric. Yeah, cannot do. You can view it in the data, but there are a few types of variable that I should let you know: the numeric, and then the vector. This is species. Oh, this is the end of the line. I thought I still have more. Species, yeah. Species is called a vector. Vector is actually just a character. We call it also character. So because this is not numeric, this is this kind of words, Citosha, versicolor, opigitica. Yeah? So we call it normally a character, but within the R, you can convert it to vector. If you call it a vector, this means you can kind of identify this as this is the level 1, number 1, level 2, number 2, yeah. So not really a character. So this is important in the coming process. If you have the character or you know that this is a vector, yeah, you need to know what the character of vector. Where are we now? Maybe we can go faster. Here we have a structure, a glimpse, this briefer information. Here we have got, yeah, the simple length, we call it the double numeric, double precision numeric. This is vector. But later when you use other data, we will see more types of data. And here head will give you the first 6 lines. You just want to see in briefly the first 6 lines. You can have yes, head, and tail is the first, the last 6 lines. But you can also assign head riff 10, yeah. So you can have the first 10, top 10. The first top 10. So what else we need to know when you're dealing with the big data? Because you know the names of the variables. Sometimes you forgot when you're writing this code. You can type the name and you get the name of the variable. Class iris must be a data frame because it's already in data frame, but it can be a table or anything. Yeah? But here is data frame. Okay, what else? This statement is important if you are having many categorical variables, many different kinds of values inside the data. So you want to know whether, if you have NA, and then it will appear the NA. Yeah? If you do the unique here. Okay. You only tells, because it's very simple table data, you only have first color, first unique, and these are the unique values, the unique content. Yeah, only Citosa, Virginica, and first color they can identify. But if you have more and more category, it will show you. Now, let's come to the figures. You want to know more about the distribution, at least, yeah, statistics on the distribution, the summary of summary, and you can have the summary for all data set, but you can also have summary for specific variables. For specific variable, you need this dollar code, dollar sign, yeah. Dollar sign and then simple length. You can have the summary statistics of simple length. So we have the minimum value, simple length, the first quarter, median, mean, yeah, the mean, and then the third quarter and the maximum is there. Same if you do this for the variable, but you can do also for the entire data set. Yeah. What do we have if we go like this? So the summary of all variables is here. For simple length, we have the minimum and the maximum, simple weight. And then for the species, because you cannot compute the mean, the variance, the median, so they only provide the count. Under the species, we have the count 50, 50, 50. Yeah, that's more or less the summary. But okay, if the data has some NA missing values, then here also appear number of NA, yeah, missing values. But here there's no missing values, so that's all we can have. Okay, let's now move on. Any question? Any remarks? Now we'll introduce you to the pipe operator. Pipe operator. This is the sign, pipe operator. This is only available when you install the tidyverse. Yeah. Because I have already installed the tidyverse, so I just need to load it. But I already loaded also actually, so maybe I don't need this. And the pipe operator, one thing you should know, this will make our work more efficient because you don't need to every time write refer to the name of the data set. Yeah, you don't have to. In the base data, in the base R, for example, you want to select here. You have to write here the name of the data set. So you should iris, for example, and then $sign. Yeah. But here we don't need, because in the pipe operator, this means that we tell the R to pipes in whatever on the left side of this sign to the right. Yeah. So here we will use the iris data. Yeah. In fact, you can consider this as and then. Yeah. We will use the iris data and then please select this variable. This variable. So that's all what this means. You don't need to write the name of the data set. This is from this data set, this is from what data set, but just mention it here. So it works. Oh, yeah. So we can select only two variables. Simple length and simple width. And you can proceed with the further data exploration. Yeah? And what else? We can still continue with this. After we select these two variables, and then, please arrange them by descending order, for example. Yeah, by descending order, following this simple length. Okay, let us see what this works. Yeah, it works. Now we have this data set. Arranged by descending order with the reference of simple length. Yeah? So we arrange the simple length, descending order, and then other variables follow as usual. That's what we have. What else? Yeah, we can view it. After we give the instruction here to this point, and then we want to view it. Let's see what this gives us. This gives us this nice table up here. Yeah, nice table in descending order. Okay, now let's see the MPG dataset. MPG dataset is the mile per gallon dataset showing the result of the survey related to the efficiency of the fuel, yeah, in the city, city MPG, as well as in the highway. Also available in the R. Yeah, let's see what it is. You can view the MPG. So here, the column, the variables, down in the row. Yeah. We have 230 something, 34, yeah, 234. First column is the manufacturer, Volkswagen, etc. And then we have the model. with this code. And this is the engine size, the displacement engine size, and year, production. This is the cylinder, number of cylinder, 4, 6, etc. Transmission, any kind of transmission. So this is categorical variable. This is category. Drive, whether it is front wheel drive, F, or 4-wheel drive, or rear wheel drive. We measure the efficiency in the city, when you're driving in the city, per gallon, mile per gallon. This is 18 mile per gallon in the city, but in the highway can go until 29, like that. And this is the class of the car: compact, mid-size, SUV, two-seater, etc. These are the data, so frequently used in the training. But there is a more efficient way of looking at the data. If you don't want to have this to scroll the big data. You can count number of rows, 234. Maybe if you have this, you can have 2 dimensions already. Number of row and the column. The structure, the glimpse. Let's see the glimpse. Yeah, this manufacturer is of course a character. You cannot compute as numeric, or double precision. And then this is integer. Here is integer. Integer. We don't have the class of numeric here. Okay, so integer, I guess you know, integer is the whole number, right? 1, 2, 3, 4, with no numbers in between. This is integer, but double precision or numeric is a continuous variable. Continuous. 1.8, 1.0, that is. Then character, of course, this kind of character, compact, OD, etc. But if it is a vector, then it has level. There's some level. For example, if we are dealing with level of educations, we have basic education, junior high, senior high, and university, for example. This we can call it, we can treat it as character if you wish. But if we treat it as a vector, then we can use it for our computation. You can make, for example, a bar chart or box plot, or histogram. If it is vector, but if it is character, you cannot. Okay. What else? The unique. Okay, let's see what it gives us. Something new from the iris related to this variable, transmission. Do we have? So they have this entry, this level. auto 15, etc. No NA, missing values. Okay. If there are missing values, just appear here. Okay. About the drive on the front wheel, fore wheel, and rear wheel. And then the year only. Oh, so they have only 2 years, 1999 and 2008. Okay, so we have some idea about the data, some glimpse about the data, content, structure. Of course, the problem we can anticipate. Yeah. Okay, what is here? We have learned about this summary. The tail is the 6th lowest observation. The class, this is showing the whether this variable simple, is it simple line? Yeah, variable is numeric or not, or other types of class. Yeah. Why you move? Okay. Okay, now again to get familiar with the pipe operator. This is the pipe operator. Now we'll apply to the MPG data. Again, I normally remind us to load or to install, if not yet here. When now with the MPG data, we will select only the transmission and the city. Let's select the transmission and the city. MPG, and then select this. So we will use MPG and then select this. So let's see. So we can see here, we have selected the transmission variable and the city variable. And maybe you want to do something else to arrange again, yeah, like the one on the, but to arrange it by the city variables according to the descending order. So we have this descending order of the city, and everything follows. Okay. What next? You already. Okay, here if you want to arrange and you don't mention whether it is descending or ascending. So this is the default actually. So if you don't put anything, this means you want to arrange it in ascending order. So this we will arrange by class, yeah, in ascending order. So let's see what happens. Yeah, the class is not a numeric, right? The class is not a numeric, but still we can have this arrange by the what we call it, the letter. Yeah? So this number first, and then start with C, and then start with M. Yeah. So this is in ascending order already, and the rest follow. Okay. Okay, that is the first file. You can have a look. And it's 11. So before we go to the next topic, I think it's just, you should break, yeah? You should have break by 11, by 10:30. Okay, can we have a break for 15 minutes maybe?
Bagus. Before
Yes.
that, you want me to launch the polling before or after the break?
Maybe before the break, yeah.
Okay, all right.
Yeah. Okay. So we'll come back at 11:20, yeah. 11:20, then we can go faster.
Okay, before the break, if you can see on your screen, we have a polling, which is a mini quiz in response to what Pak Agus have presented before. So if you can please, choose and refresh the mind again. And you can, please note that you have to submit all the questions. Sorry, you have to submit all the answers for the 3 questions before submitting.
It is very simple quiz, I believe. And you can do it in 1 minute, most of you. So
right. Maybe we can give we can give the time for 2 minutes, Pak.
Yeah.
All right, okay.
Thank you, Tari.
No problem. We have 25 participants who have answered, so waiting for the others.
Okay, maybe we can go to break. Let me see,
Okay, yeah.
Tari, how many?
Okay, there is a 30, but I will let the questions on the screen so the participant can take a break. And after that, we will back. How about that? Okay.
Okay, thank you. Hello. Can we resume? This is the results of the.
Yeah, Pak. So
Yeah,
we
thank
have
you.
36 participants who answered the quizzes.
Thank you, Dari. It's pretty good. Yeah. What packages you need to install to be able to load the iris dataset? 44% says none, which is correct, yeah? You don't need to install anything to load the iris dataset. But to work on it, to process it, we may need to install some package, yeah? But just to load the data, we don't need to install anything. Number two, what package you need to install to be able to load the Gapminder dataset? I think Gapminder we will see other days, but let's see. Almost 40% are correct, yeah? Is it Gapminder? Yeah, Gapminder dataset. So the correct answer is what? 47%. So none of them. To get the Gapminder dataset, we need to install the data. The way to write to install packages and then between parentheses, Gapminder. So this we'll see after this. So it's good that almost 50% are correct, yeah, 47% correct. And number three, what packages you need to have in order to be able to use pipe operator? Yeah, 56% are correct. Okay. So perhaps 50% of you are still a bit new with the R, but 50% are already very familiar, I think. Yeah? That's good. Now that we have seen the step-by-step on how to execute the command and then the various functions that can be used for data manipulation, data exploration. Now we'll go much faster. Yeah, we'll be using this PowerPoint presentation just to show you the results. So when I use this code and then I execute, this will be the result. Okay? So you can go much faster, and at home you can try. Copy paste this command and the R, and then you execute, whether you get this output or not. Yeah. So the main idea is just to give you understanding of what function can produce what, yeah, and then later when we are dealing with the data, you can see how they come together to help us in the data manipulation and data exploration. Yeah. So you can follow this, and then later you can do it your own by copying this, whether you can get this one. But the objective now is just to give you some idea that those functions can do many things, that when necessary we can use them. And then there will be some example which will put together all of this function and see what happens. Okay, let's move on using this. What's this? More on data management, data manipulation. Some we have seen, yeah. You can just follow later. I will start with this one. You have, yeah, if you run this, you will look at this, yeah, and you have seen it. And then let's move on to something new. This one. If I install it,
Pinter lihat YouTube dia.
sorry. Okay. This we have seen, yeah. We have this kind of instruction, select, yeah. But I will just explain a little bit, starting from slide 9. This is an example of using deployer. Deployer is also within the tidyverse, yeah. You don't need to install again. Just load it. Sorry. This is the pipe operator again, yeah. But this we use it to select a column. Select column, there are many ways, of course, but one way is to use the index. We identify, we provide information to the R, which column 1, column 2, and 4, yeah, for example, select column 1 to 4, okay, and then use this instruction. This data, select this one. This, starting with this hash is a comment, yeah. You don't need to write, it's okay. But this one is the command. You have to write it. Okay. When you apply this to the data, you get these results. You get column 1, column 2, column 4. Okay. You can also select variables by column name. Column name, yeah. So this is reminder. Select country, select years of population. You will get this. Country, year, population. Like that. What else? This one is, yeah, cell by name, yeah, by name. Species, I want to have species from the iris, sepal length, sepal width, yeah. And we got this. In order of what you read here. So if you recall the data set, species is in the most right column, but here because you specify it first, then it comes first. Yeah. So this is selecting column by using index or selecting column by the column name. This is more or less the code. Then let me pick up on. What is this? Okay, this applies to Gapminder data. Gapminder data, you need to install this again. Install, and then now you can use it. I've installed earlier, and you can use it. Here, for example, you want to select country and year and population. Country, year, population, come out. The whole observations, the whole rows, yeah. Then now selecting row, maybe you want to have to sample the data set, yeah. Only for rows which have only rows with this value 7.9 for the simple length of what's this? Yeah, I'm gonna see. Because this is the maximum of the simple length. So in other words, you want to know what observations, what rows or what species is the maximum, having the maximum simple length. So here you are. Why I put this dash? Okay, this is the new one. This is the remarks only. So this is the function, the instructions. Iris filter all any variables. Yeah, this sign this value, and then with this number. So this will give you the row with this number for simple length. Yeah. So you got this simple length of 9. So you know that the characteristic of the flowers with the maximum simple length. This is Virginia species, but with a very small width of petal, and this more or less a high length of the petal, and but small width of the sepal, yeah, like that. So that is what we got. And this one, suppose we want to have a specific also rows with 4.3 appear in any column. That's fine. In any column. So you got this 4.3 here, and then we have the whole rows, and then line 2 4.3 here, we got the whole row, and then 4.3 here, we got the whole rows. This is more or less the codes if you want to get this. Okay, you want to have observations of all species of Setosa. So only Setosa will be selected. So you use this Setosa. Okay, you just change the parameter of this C here. Yeah. Okay, and then what's this? This is using the diamonds dataset. Show you the diamond dataset. Diamond dataset is variables called the carat, how many carat? The cut, whether this is ideal or premium or fair or good or poor, cut, and then the color is coded like this. The clarity coded like this. The depth, and then the price, yeah. So now, for example, you want to know what this. All rows with ideal cut, yeah, with ideal cut. Ideal cut is the best, of course. The cut is really fine, yeah, ideal. So we got all of this ideal. So this is how you select a sample by row, and then before we've seen selecting a sample by column. We have seen from the summary, you've seen from the summary that the maximum price of diamond is this 18,823 US dollar, And suppose you want to know the characteristic of this, and you just put here again the number, and we get this, the answer. So it turns out that the most expensive diamond is not the ideal one. Yeah? It's not the cut with the ideal cut, but this is a premium. Yeah. Now, of course, price is depends on many things. Yeah, not only the cut, but also maybe the demand. Yeah, and the location, etc. But this is the premium is near fine, yeah, near the ideal. So could be reasonable. And here you can have either or, yeah, either or, not only one specific element, but here either or. So you want to have the rows with ideal cut, or the rows with color E, or the rows with what it is, S is clarity S12. And those are the best characteristic. So we have here, not everything is ideal. Yeah, not everything is ideal. Why? Because we also said, or the color is E. This is E. So even if it does not satisfy this column, if it satisfies this column, and then we put it in our sample. Yeah, okay. So this is either or. But we also can have N, so multiple criteria. Multiple criteria. Yeah. So it has to be ideal, and at the same time color E, and at the same time clarity S12. So it has to meet these three criteria. So this is the way you want to have this multiple criteria. So if you apply this, you see that the cut is ideal, all, and at the same time the color is E, at the same time the clarity is S12. Okay, this is how you get this. This one. Okay, this is also interesting. Suppose you want to, you're using iris data, and you want to select species only Virginica. So this is the code. Data set, and then the variables, and then this is the category. You only want the category of Virginica. So it will come out like this one. The species only Virginica, yeah. From top to bottom, 150, all of Virginica. And here, using the Gapminder, it's good if you exercise this, yeah. So you know the data, familiar with the data, and then familiar with the functions to apply. Here, suppose you want to select only from the Gapminder, yeah, data set, only Indonesia. Yeah, Gapminder, country Indonesia. And you got only Indonesia. Yes, Indonesia. So this is the way you sample the data set by column or by rows or by specific values even by multiple criteria even. Yeah. Okay, what is this? Other than, suppose you want everything except Indonesia. Yeah? All countries except Indonesia. This is the efficient way of writing this. We put the exclamation mark here. Exclamation mark, this shows that we don't want Indonesia, but we want everything except Indonesia. When you do this, you get all countries here except Indonesia. Okay. We want to explore Indonesia beyond 2000. Yeah? Beyond 2000, how is the situation with the variable in the Gapminder? In the Gapminder, you have information about life expectancy, the population, GDP per capita, yeah, and it's organized by continent, also by country. So if you want to know Indonesia, for the year 20 and above 20, you have only this results, yeah, because the Gapminder is not every year. They have 2002, 2007, beyond the 20. And this is the characteristic. Life expectancy, this one in 2002, 70 in 2007. So this is, if you want to have a specific value, this is Indonesia, and meeting some specific criteria. Indonesia, but beyond 20. The deployer provides us with number of functions. This is called functions. This can help us in the data exploration and manipulation. Select, this is to select columns. Filter is rows. You're talking about rows is filter. And then there is also a muted. Muted is to transform variables, to create a new variables. It's okay. Arrange to sort the data, then summarize, and then we have also summary. And we'll show here an example using that one. This one's fine. Yeah, this is also fine. You want to select and put them in an object. So design, by the way, this means that you process this and then put everything in this object. You could also use equal sign, but this is more compatible with other ARS functions. Yeah, so better use this sign. Again, want to select a sample. Yeah, put it in the sample one object. Those flowers, iris flowers, data with sepal length, sepal width, petal length. That's all. Yeah, and you want to see only the first 6 lines. Okay, this is what happened. You got only the first 6 lines. Yes, sepal length, sepal width, petal length, and that's all. Species. No, only 3. Yeah, sepal length, sepal width, petal length. Okay, what else? This one, you want to select sample again, put it under sample 2. Yeah. This is the one that I should introduce. Double what do you call it, the column. This means from this column to this column. So select from this column to this column and put it under sample 2. And then you want to see the first 4 lines, but this is 4, yeah? The default is 6. Okay, and then from that, you want to, oh no, this is different. Select sample 3. Select sample 3. You can refer to the name like this, but you can also refer to the column index. 3 to 5. 3 to 5, something like that. Okay. What is this? This is, I would like to introduce this sign. This means you are hiding this column. Yeah? So sample 5 is the whole set of iris, but hide this variable, this one and this one. Yeah? So if you hide this, you can have only petal length, petal width, and species, because you hide sepal length and sepal width. And filter is for rows. What can we do with this? Filter rows to find much. Okay. We filter rows, yeah, which match some criteria. What is the criteria here? For example, the first 3 rows. The first 3 rows is very easy. Actually, we ask the whole thing, yeah, Sitosa, because they want Sitosa only. So the species must be Sitosa. So you kind of asking, is the species Sitosa? This sign is not the same as equal, yeah? This is kind of asking. This is a logical statement, asking whether this is Sitosa. If this is Sitosa, and then put it here. Okay? Filter and put it here. And then here, please cut only column 3. Sorry. Column 3. Okay. Select the last 5 rows. Okay, it's more or less the same. Muted is to transform the variables. Yeah, we want to create a new variable, yeah, called sepal L0.5. This is just my initial, but actually we want to select the sepal weight, yeah, which 50%, it's only 50% of sepal length, yeah. So we want to select all rows, all flowers, all species, but with sepal weight only, not only, greater than half of the sepal length. So the sepal weight must be greater than half of the sepal length. So whatever the species, whatever the whatever the species. And then this is the code. They will call 1. Call 1 is the sepal. No. This one, and then we want only the sepal with. Oh, we have got the sample here, right? We have got the sample here. Got the sample. So this, we put it in this call 1 in this one, and then we just want to table it. This is the statement to get the frequency table. So we have this put and range. Range also an important one. Range in ascending order. Ascending order. You don't need to write anything here. Yeah. But if you want to have a descending order, you need to put descending here. So basically arrange to arrange the order. This is the output, you must cut this one. This is also important, the difference with summary and summarize. For summary, we have seen, yeah? You have summary. This is summary of the most important statistic that shows the distribution, yeah? Mean, minimum, first quarter, median, mean, third quarter, and maximum. Yeah. But the summary, we can have the summary but it's only for specific variable. Yeah. This is Irish data only for simple width or only for simple length. Yeah. But the good thing for summary, we can use it in combination with the grouping of the before that summary gave only the grand mean, unit, the overall mean, yeah, the overall mean. And the good thing is that we can use it with the group by functions, yeah. So, for example, we have this. What data is this? The iris. You want to have the mean of each species. Yeah? So you have to have the mean classified by species or grouped by species. So you can have these functions in this code. Yeah. Summarize. You summarize here and here. You cannot see this one, but you group it by the species. And here you can get for this one, mean is this one, the first color, the mean is this one. That okay. This is better examples, for example, with the gapminder data. You want to group the countries, because you have countries, you have continent. You want to group the countries by continent. Okay, by continent. And then you want the mean of the population. The mean of the population of the countries, but grouped by the mean. Yeah. So if you use ASEAN data, we can group it by ASEAN category, CLMP, non-CLMP, for example. Here, by continent. So Africa, America, Asia, Europe, so the continent. This is the mean of this group. Yeah. So summarize, give the mean of the entire data set or the entire group, depending on whether we want it by groups or no. Yeah. This is same thing, but by operator we have seen. Okay, then I will show you one more PowerPoint presentation to give you more feel about the data manipulation. Okay. It's not here. Should it is. Yeah, just give more functions and some just review. So you will be more familiar with all of this function and how we can use it. This is a simple one. This is the way you also select column by name. Yeah, arrays, and then this C is concatenate. Yeah, this combination of this variable and this variable. This is another way of selecting. This is from the base R. From the deployer, from the new package, you use here select, yeah, select column or select number, but this is the other way of selecting a sample. Okay. Go down, you've seen more interesting one. Okay. We have seen this also earlier. Okay, we have seen this, yeah. Let's see. Okay, that's more or less about data exploration and data manipulation. You have seen various ways of selecting columns, selecting rows, selecting specific values, meeting some criteria, meeting multiple criteria, and how to create the new variables, how to transform variables, and then a few more. Now let's move on to the maybe a bit more fun, yeah, a bit more fun. Please have a look all of these materials. I also provided you the scripts, yeah, you can just copy and run it command by command and see if you get the same output here. And you can also try to type your own, so you will experience the issues when you're writing code, because sometimes just a comma or some capital letter, small letter will give you a problem. But that's all, I think. Well, you need to experience yourself by looking at all the materials I provide you. And now let's move on to the one a bit more fun. Where is it? Here. Yeah. Now come to the data visualization. Data visualization, we will use the ggplot. Yeah, plot. This is the one. Yeah. There's also the script. You can copy and run it and see if you get the same results. And this, we use ggplot because it is more efficient, yeah, more handy, and it's easier to understand. And you don't need a very long statement, which can be confusing. Yeah? With some statement, you need to have wrap in parentheses, and then wrap again, and many parentheses if you use the base, but not here in the ggplot2, which is under the tidy verse. Yeah? So it's neat, quite neat. Let's start. What else? We will use what it is. This is the same MPG data. MPG data set. Mile per gallon. This is provided by this US EPA, and we have seen there's 234 observations and 11 variables. Let's show to make some nice graph out of this. So this is the variables I mentioned earlier: manufacturer, model, displacement, engine size, year, cylinder, transmission, etc. Now let's get started. If you want to draw a plot, yeah, graphics. So imagine you're painting. You're painting. You first have to prepare your blank canvas, yeah, your blank canvas, and then you put some layer. You put some sketch, maybe with a pencil, yeah, and then you put color, yeah, and then put something else to make it nicer. But here it's not only to make it nicer, but also to provide more information, to help us dig more information out of the data. So let's start with this statement. If you run this statement, unfortunately we don't have time. You run this statement, you get the wrong message. So this is ggplot. This data MPG, mile per gallon, and we need to have some mapping. And this is the aesthetic part. This is the variable. We want to plot X and Y. Using this data, where X is the displacement, the engine size, and Y is the city. So here we want to look some association between the mileage performance in the city for different kinds of engine size. Yeah? Think logically, the bigger engine, the poorer the mileage performance. Yeah. So let's see. But if you run this, you'll get an error. By the way, for the ggplot, yeah, there are three. Well, related to this error, why it's an error? Because you did not install the chip deployer, the tidyverse. Yeah? So you need to first install the tidyverse. You need to first install the tidyverse in order to perform this. So here, install package, install dot packages, and then in between parentheses, you write the name of the package, tidyverse, with the quotation mark. Yeah, don't forget. This is the way you write instruction to install. Install tidyverse. And then to load. Install is just to have the package in our computer, but not in our R environment. You should put it in the R environment by this statement, this command. Library tidyverse, put them in the command, yeah. And then this is the instruction we have. Oh yeah, ggplot2 library. Yeah? This is the same command we have earlier here. This one. And this does not work if you don't have install this and load these packages. Okay. When you have this, and then you run the whole thing. Click and run, and you got this one only. This is what I call the empty canvas or the blank canvas, where you will start to draw something here. Huh? But this, not just a blank canvas that already have the skill, because the ggplot knows that you want the variable is displacement and then size here, and this is a skill, and the city performance. They already provide this, but they don't know yet what to put it here. So we need to add something, add a layer. Yeah? We need to add a layer. Just put the plus sign here. Put the plus sign. And then what do you want to put there? For example, we want to put the point, the dots. Just put the dots. This is the statement. And you get this plot on your canvas. So no more blank, but you have dots scattered around, but more or less showing the negative relationship, right, between the engine size and the city mileage. The greater the engine size, the poorer the mileage in the city. Maybe also in the highway, I don't know. So you can also try with the highway variables, yeah? In place of the city, yeah? Here, you can change to the highway. Okay, we have this. So what next you want to do? Maybe you want to add line, yeah? Add line, connecting dots. So you put another layer, the line. This is the original statement here. And you could add, yeah, plus the add here, and then geom line, okay? So you got the lines. So by the way, what is this geom? What is this mapping? Yeah, the ggplot works under they call it the grammar of graphics. Grammar of graphics. Grammar of graphics is not about the structure or the grammar of writing up the title, yeah? But this is about how we should work with the ggplot. We have to have 3 components should be there. Number 1 is the data. What is the data? So ggplot, and then explain what is the data. You can use the MBG, you can use iris, anything you want. And then mapping. Mapping is telling the star how you want to do the aesthetic part of the graph, yeah. So this is about telling R about what variable to be plotted. The x1 is this, the I1 is this one, and geom. The third component is geom. Geom is about the geometry, the things related to the size, to the mapping. This not the mapping, the plus the line. Yeah, this is the geometry. We call it. And actually, there are many more arguments with the eyes. We will see later. And there are many more arguments with geom. So these are the three most important components. The data, you should have the data. And then you should specify the mapping, how you like to plot the variables, what variable to be plotted. And then here, what else you want to add on it. Here, and okay, we have here, right? Now, next, suppose we want to add color, to put color to the line, yeah? So maybe it looks nicer. Okay, we can do that. Here, the geom line normally is just blank like this. Now we can assign color. With color equal to, this is magenta, for example. You can also use red, green, yeah, brown, etc. But between parentheses, between quotation mark, like this. And you got this lines, color. Maybe you want to have a clearer trend, yeah, but smooth trend. So you need to add this geom smooth. Geom smooth will give you the trend, the smooth trend, not the straight line. Yeah, trend like this. And what is this? You want not the smooth trend, but the straight line. So you can change the argument of this geom smooth. Put the method, the LM, linear model, and you want the standard error, is equal to, and then you see the standard error. I don't know if you can see it in the right most part of this graphics. Yeah, here. This is standard error, the shadow there. And then what suppose here it is standard error, very clear. You put it back in the smooth, it's okay, fine. Yeah. So just drop the argument. You get it in the smooth again. Now you want to put color to the dots and give size, yeah, give size. So the dot is under this point, right? Geom point. So you go to the geom point and then you put size equal to what? 3, or you want to be bigger, 5, it's fine. And then here you put color here as well. Yeah, color equal this code. First thing you need to know that this argument, because this is under the geom point, so this will apply only to those related to the point. The point size will be 3. The color will be this code. Okay, and here the color is this one according to that code, and then the size is this one. You put 5, it will be bigger. And that's all. Yeah, by the way, about this code, we provided you with this URL. Yeah, you can go to the internet. This is one of the many. Suppose you go here, and then you will get different colors with this hash code. Yeah. See, you can go here. You just pick whatever color you would like, and just copy this and paste it to the argument on this geom point or geom line as you wish. You put it here and you get this one. Okay, it's quite handy. And then order this. Yeah, in this folder and this file, I will also provide this manually. If you suppose the internet is down, and then you can just copy from here. What else? The pipe operator. We have seen pipe operator, but this is here used to facilitate our work with the ggplot2. Yeah. This will make the statement much more efficient. For example, this one. Here, you just mention the data, and then, yeah, and then this is, you call it this, and then ggplot2. And here, you don't need to mention what is X, what is Y. Because they know, the ggplot know, the first one is X, the second one is Y. So it's more efficient working on it. And just put the geom point, and you got the same blank. Oh, here it's already put some. Yeah, we put already some geom, so point. Yeah, so we have the dot. If you don't have the geom, this is just a blank canvas. Okay, now we can move on again to put the size equal to 3, bigger than this one. This is small. This is bigger. That's equal to 3. And this is one thing that I would also to introduce, the color. The color should not only be one for all, yeah? So not everything is magenta or everything is red, the point, but we can use the color to indicate the level of, in this case I use the driving. So whether this is front wheel drive, whether this is the 4-wheel drive or rear wheel drive. So we have more information in this same canvas. So green is the, you see green is the front wheel drive, the pink is the 4-wheel drive, the blue is the rear wheel drive. This already can tell you that for the rear wheel drive, the blue one, yeah, they not only have bigger engine size, nothing here, blue, only this part, and they have poor performance of city mileage. But the green, yeah, normally a small engine. The green is the 4-wheel drive, normally a small engine, and they have very good performance in terms of the city mileage. The more information we can see from this graph, so not only in terms of the aesthetic, but also in terms of the information. Those help us in understanding the data better. Sure, if you want to split the graph, because we have 3 categories, you know, the 4-wheel drive, front wheel drive, and the rear wheel drive. Want to put it in the different charts. This is, we call it facetting, yeah, setting. You do the facetting. This is the statement, facet graph, and this is tilde, meaning by. So you split the canvas into how many categories of drive. Drive on the 3 categories, so we have this small. And here we have one line, yeah, only everything put in one row. You want to put it in 2 rows, you can add argument here and row equal to 2. So you will have row, the upper one, the lower one. This is empty because we have only 3 categories of driving. This is if you want 3 rows, then you got 1, 2, 3. Labels, you can put labels easily. Yeah. Up to here are the same command, the same codes. For setting, yeah, this is the setting, okay. And you wouldn't to put anything else, you just hit plus here again, yeah, plus. Plus you want to add labels, so just labels. First you need to know what you want to put in the labels. You can assign legend for X, legend for Y, and title. That's all. And you got this, the title. This is the legend. The label for X and Y. What else we can do? What is this? Theme. Yeah, this is theme. Theme. Maybe just make it nicer. Theme is to kind of provide the theme whether it's black and white or whether it's bright or no. Yeah? This is if you use the black and white. So the writing up here, head of the column is black. And where is the statement? Suppose you want to change the theme into light. Yeah, the light. So you got this light up. Yeah, the title. So that kind of things that the ggplot can do for us. It's quite easy. Yeah. What is this? Sim. Filter. Okay, filtering. Yeah. In addition, we can also, after this many layers, you want to filter. You want to filter select only certain criteria. Yeah? But for that, you need to make sure that the data is a data frame. Yeah? The data is in data frame format. If not, you can apply this code as data frame to this data, and they will change it to data frame. But again, as I mentioned, there are few functions which are not really compatible with other data frame. Yeah, so it's better if you have already this in data frame. But if not, you can change it and then see if there are functions which not compatible. You will get the error sign. Yeah. Okay, filter. This is the filter. Suppose you want only the cylinder greater than 4. Yeah. For those car with cylinder greater than 4, what happened? So here, up to here is still the same labels, then sim, yeah, okay. So where is the filter? The filter must come before you assign the ggplot arguments, before this. So apply it to the data at the beginning. This we have two statement. One is to mute it, to change, to transform the displacement into the logarithm of the displacement. For example, because in some cases, when you're dealing with very big numbers, you need to log transformation. So this is the way. This is the displacement. Then this is the new variables, and this is the way you want it to be transformed using the log or using other rules. It's fine. But the filter is here comes after this mutate filter. It's very simple instruction. Cycle greater than 4. Okay, cycle greater than 4, and then continue with the whole process here. So what we get? We get this more or less similar table, but with the shorter scale, because we limit the sample only to those with cylinder greater than 4. So this only with cylinder greater than 4. Actually, you can also reflect the cylinder measure by assigning the color. So mapping the color to the cylinder. Here, the different color between this and the middle panel and the rightmost panel actually is redundant. It's not really useful. Because without the color, you already know that this is the four-wheel drive, this is the front-wheel drive, this is the rear-wheel drive. So just make it nicer. You have different color, make it nicer. But you can use this color to be more useful if you map it against, for example, the cylinder, like that. Okay, so this is more or less the way you do with the ggplot2. You can see the later codes here. What can they do with this? And there's an explanation here, and you can copy, paste, and try what you will get from this codes. So it's very simple, neat actually, and you just copy the functions and see what you need to change from it. But actually, what is important is coming from what you want to see from the data. And then, okay, I want to see this, and then you need to assign color so they can reflect in this category example. Okay. With this, I think finish today's session. Again, my message is just for you to try at your own. It's only very short training, so just to make you more or less understand what the different codes are available and what they can help us, how they can help us, and what data we can use and how we can manipulate them. So, any question on this? Maybe Tari has some quiz. 2 minutes quiz, please. Okay, any question? Otherwise, we can go with this quiz very quickly. Number 1, grammar of graphic has to do with correcting the title of a graph, or has to do with the geometric or mapping. And what is the other one? Putting labels on the graph. Grammar of graphics. Number 2, what do you need to install for you to be able to draw various kinds of charts using the Gapminder dataset? So you want to use the Gapminder datasets, what packages you need to install. Install the tidyverse, install the Gapminder, install the Quandle. Maybe you have not seen here the Quandle. Number 3, which one is the correct answer? If you need to install the tidyverse package, this one is the correct way of writing. If you want to install this, A or B or C. Okay. Please send your answer. 2 minutes. Then we can have we can conclude today, and we can meet tomorrow with the regression analysis. Regression analysis. Yeah. Yeah, tomorrow session 3 is in the regression analysis. And in the later part of this morning, we will look at the time series.
We have 32 answers so far, Pak.
Okay. Can we see the results?
Okay.
Okay, 69% correct, number 1. The grammar of graphic has to do with the geometric of the mapping. Yeah. Number 2, what need to install? Gapminder, okay. Okay, also very high. Install the tidyverse, of course, and then install the Gapminder. Then you can work on it. Okay, the Quandle you have not seen. Quandle is for exporting data from the URL, from the URL and the XML. And number 3, what is that? Which one is correct? If you need to install, how to write it? Number 1, maybe you not very clear. This small, but the correct one is number B. With the small I, install with small I. Number 1 is install with capital I, so maybe you don't see this. Okay, but only 60%. Yeah. Okay, thank you very much. And have fun at home. Try to use the codes and change the data set. Yeah, and see if you experience some problems, because only in this way you can learn, yeah? And in this way you can learn. You have to copy the scripts and then do it your own. Any remarks, question? If not, again, we can close this morning session and see you tomorrow at what time tomorrow? 8:30, yeah? 8:30. I will put the floor to Tari and ASEANstats.
Panik,
Mbak Anik, Pak Eka.
Panik, you still mute.
Sorry again. Thank you so much, Pak Agus, for today. As for all participants, this is the end the training session for first day, and we will see you again tomorrow at 8:30. So thank you so much, and stay healthy, everyone. Thank you.
Okay, bye.
Thank you, Bagus.
Thank you,
Terima
Pak.
kasih.
Thank you and
Terima
see you
kasih.
tomorrow.
See you
Bye.
tomorrow. Bye.
Thank you.